Okay, welcome back to the tutorial session once again, and we will discuss some questions based on integration. So let me share my screen. I hope you can see. So this is the first question. As we saw that the last, I think week 5, there was complete discussion regarding the integration, all kind of like one, let's say double integration, triple integration, one time integration. So all had certain meaning under certain condition. They all have some geometric meaning. So if I ask you here that let's say if I give you a function, of course, what function which I'm talking about are non-negative. Then certain functions, if we have of this type, then is there a geometric meaning behind the integration a to b fx dx?
Yes, we can associate a meaning to them.
Yeah, and how?
Like for for the single variable case, we
Mhm.
can say that it is the length of the function up within the given limits. And in case of a two
Um,
variable integral, it's the okay no, for single variable it's the area under the curve.
yeah.
For double variable, it's the volume within the given limits.
Okay. Yeah. This is what you said. It's correct. But let's see some idea behind how to see this being as a, let's say, area or volume. If I just simply see the first part where I'm trying to say what is integral a to b fx dx, and if I try to change it to this form, do you mind? I think no, right? You'll not mind if I write this.
No.
Yeah, this is one parameter I'm just writing independent of x. And if I integrate with respect to y, then it is simply y and the limits are 0 to fx. And then you have a to b fx, sorry, dx, and it is just a to b fx dx. Right. So what we are exactly doing, let me just try to elaborate here a bit. So you have this is x and this is y, and you have certain fxy your function. Let me draw it more clearly. Suppose this is your function, then what you are exactly doing, you are trying to reach from this point to the function. So you are reaching, let's say I am trying to show you the meaning of this part. You are trying to reach from 0 to fx, this is your fx, and of course, you have set a limit from where to where you have to look. It's from A to B, let's say. Suppose it can be negative also. I can go from here minus A. A can be negative also. So I can start from here. And this is how you have to compute. So what we are doing, we are just taking this kind of length and certain kind of height, right? It's like it's not directly length into breadth, but it's kind of that you are writing the length part and then you are going from the breadth in the sense from one function to a function which is fx, and one function is fx equal to, I mean, y equal to 0, because you are starting from y equal to 0, because you are taking function to be non-negative. So roughly, this is how we see that it is nothing but the area. Just like we see the area for the rectangle length into breadth, it's a similar kind of thing. Of course, not same. So therefore, it should give me the area under the curve. And a similar kind of structure, one can see that if we have, let's say I have written it double integral, but I hope you will not mind if I write it as 0 to f of xy, and then dz dy or dx dy. If x I'm writing, it will be from a to b and then c to d. Right? It can be written like this. Again, if you see directly, if I draw it, then certain a is here, let's say, right, and certain, sorry, yeah, a is here, b is here, c is here, d is here. So we are going from that good at drawing, but let's draw. It's something like this. We have from a b c d part, and then we are going to the certain surface which we have defined, and then we are just simply going to that surface, we are reaching up to that surface, and this is what we are computing. So since we do not call for three variable as a area, we call it as a volume. So this is how we see. So x and y, we are bounded by this region, and then the above height has been bounded by your given function. So this is how your base and height, everything is being bounded. So you should get a finite answer. Therefore, the volume is nothing but the finite, and the integration makes sense. All right. So I think this should be okay. What I want to say here. So
Yes,
yeah.
it's
So
okay.
yeah. So this will, as you said, it is area under the curve, and this is volume under the surface. Okay. Yeah, so let's go to some question to approximate the area under the curve. So as we saw, we can partition our given uh, say domain in such a way that we can approximate the area. Of course, the exact area is nothing but the integral, but we have seen that integral meaning is nothing but certain limit. You see, remember, the integration is nothing but a limit of certain sum, which we call as Riemann sum.
Yes.
Yeah, so if I just try to approximate that area through certain sum, that I have to partition them. So what I have written is approximate the area under the curve over the region which is a rectangular region. In fact, it is a square region, by partitioning the rectangle into four smaller rectangles and compare it by computing the area by integration. Yeah. So let's can you quickly compute the area so that we can have an answer that we have to approximate the area by certain number. Yeah, can you compute that? As we agreed, area is nothing but the double integration, and volume is nothing but the triple integration. So since your area is under the curve, so 0 to x square minus y. And yeah, I think it's correct, but the way I have written it should be like this: 0 to 2, 0 to dz, dy, dx. Of course, the way I have written it, you may not be familiar. You may be familiar with this fact, maybe fxy dx dy. Yeah, I think this you might know, but I'm writing in this way.
But this form gives the volume, na?
Right, it should be volume. So yeah, let me
Like
write it.
only dx dy integrated should give us the area under the curve, under that
Yeah,
function.
right. It should be, yeah, it should be volume. Yeah, compute volume. Yeah, is that okay now?
Yeah.
Yeah, this is volume. Sorry, my mistake. Okay, so can we do it?
Yes, we can.
And whenever we have to compute certain volume, then just we need the base. The base is starting from 0 because the function is non-negative. We are assuming that, and it will go to the curve. Curve is 3x square minus y, and then rest is the limit for x and y. But x and y is anyway given that x lies between 0 to 2, y lies between 0 to 2. So I think this meaning is pretty clear. And therefore, if we just simply integrate, it would be 0 to 2, 3x square minus y dx dy. And this will be, how do you integrate? You can integrate x first, y first, either of them.
You will get 4 by 3.
4 by 3, really? I don't think so. Let me just say 3x cubed by 3 minus yx 0 to 2, and then I have to integrate from 0 to 2. I'm integrating first with respect to x. 0 to 2 is x cube minus xy. 0 to 2 dy. And this is 0 to 2, 8 minus 2y dy. And this is nothing but 8y minus y square times 2 by 2, 0 to 2. And this 8y minus y square from 0 to 2, this is 16 minus 4, which is 12, right? There is no by something, it's 12, right?
Well, I did first in terms of x, and I got 4 by 3 as the final answer.
You did with respect to y first?
No, with respect to, yeah, with respect to y first.
Okay, let's do 3x square y minus y square by 2, 0 to 2, then dx 0 to 2. This is or equal to with respect to y, so I have to put 6x square minus 2 x 0 to 2, and this is 6x cubed by 3 minus 2x 0 to 2. It is 2x cubed minus 2x from 0 to 2, which is 2 times 8 minus 2 times 2. This is 16 minus 4, which is 12. They are same, right?
Okay, silly mistake on my side.
Ah, okay. So, all right. So, we got volume to be 12 units or whatever unit, whatever. I don't have the units here. So, okay. We have certain volume and I want to somehow approximate the volume with the help of Riemann sums. So, do you remember how to partition? This look at the first of all the domain. Okay, the domain is 0 comma 2 cross 0 comma 2. So if you remember, since it is three-dimensional figure, so I have to draw. So it's, let's say this is 1, this is 1, this is 2. And I simply have to just it should be in xy plane. Yeah, this is a okay 0 to 2. I'm sorry, I think it is all. Yeah, so this is nothing but here to here and then here. And I have to partition this graph now. So what will I do? I will just simply partition into four rectangles. It is written. I will partition into this way. So what are my coordinates then? This is nothing but 2 comma 0 comma 0. This 1 comma 0 comma 0. 0 comma 1 comma 0. 0 comma 2 comma 0. This is okay, right? And this is 2 comma 2 comma 0. Now, I have partitioned my set now. And what is the way to do it? Like, and certain graph is, of course, certain graph is above to me, and certain thing like this. I have certain surface which is being, if I take the limits of x and y, it will give me certain values of z. Now, therefore, if I just partition into four these rectangles which I'm writing, so volume, if you remember approximately, this is sum of, I have to choose certain points. Let me choose certain points here. I will choose this point, this point, this point, this point. If you remember, we have to choose one point inside those uh, partitions, and each time, let's say if I choose a point xij, yij, since partition is from j from 1 to 2, I have just taken two box. I have just partitioned my x length by half, y length by half. So I have only two partitions. So j equal to 1, I equal to 1. And certain delta x ij, delta yij. Do you remember this?
Just a minute.
Okay, how do we compute? Okay, let's look at let's look at degree one. We have a curve and we have a partition A to B. Yeah, sir said you can take, let's say, N1, N2 up to Nk. And for
Yeah, I
each
think
you
the
put
notation would be just xi and yj.
xi and yj. Okay, let's write that. Xi, yj, xi, yj. This is okay, right?
Yeah.
Okay, so let me choose the points. So my points, if I'm choosing middle points, half half. This will lie in the this one. Where it will lie? Can you tell this point? I mean, I should say half half comma 0. Then 3 by 2, 1 by 2, 0. Then 1 by 2, 3 by 2, 0. And then 3 by 2, 3 by 2, 0. Yeah, they lie somewhere, right? If I just look at this one, this will
And if you
have
got
this one,
one,
right? And I think this one, it will have this one.
yeah.
This one, it will have this one. This one, it will have this one. So I have taken all distinct points from each section now, and volume should be approximately the way which we have written by partitioning this. All right, so now can you fill the gaps? So f of half comma half comma. Okay. I think points I have to choose x comma y. I should not write z part. But I think you understand what is the meaning. I am projecting, let's say, this part into xy plane. So I will get this for uh, R1, R2, R3, R4. And I think this is why the points are like x and y only, because the function is, it has to have only two coordinates, x and y. Okay. So half half, and what is this delta x, delta y? Can you tell?
Delta x is the size of each interval on the x-axis. Delta y is the size of each interval on the y-axis after the division.
Yeah. So the way we have partition, can you tell the sizes or the volume? I should say this is nothing but the volume of your smaller rectangles. Yeah. If you see your smaller rectangles, what are their volumes?
Area.
Area. Sorry. Area. DA is the area. Yeah. So if I look
In
at the
our
smaller,
case, the magnitude will be 1 for both of them.
right, this is how we have partition. We have just partition into only unit rectangle. Okay, so therefore this will not change the value. I'm just writing this plus half of 3 by 2 comma 1 by 2 plus f of 1 by 2 comma 3 by 2 plus this. Can you compute and say what is this?
Yeah, show me the function once.
Sure. Function is 3x square minus y. Let me write here f of x1 3x square minus y. Okay, let's compute 1 by 4 minus 1 by 2 plus 3 times 9 by 4 minus 1 by 2. 3 by 4 minus 3 by 2. 27 by 4 minus 3 by 2. Alright, let's solve 3 plus 27 plus 3 plus 27 by 4 minus 1 minus 3. This is 6 plus 54 plus 6 by 4 minus 4. Minus 4. Is that okay?
Yes.
Yeah, so your volume approximately what we got is 11, and you remember what is the exact volume?
Exact was 12.
12, right? So how we are very near, right, to our exact answer, and the issue is that we have partitioned the set into only into one partition. If I could have partition, let's say this square, if I partition it more, then it would have given me more fine, more closer answer to 12. So it depends on mm, how many partitions it have, as many. So this is why you partition it in so many, let's say n. When you take the limit, it will be very close to your volume. So I think this is why we say that volume is nothing but the, in fact, it is equal to the limit of certain SNs. But these SNs has to be in such a way that there are n partition. Okay, this is what I want to show you, in just to say that we really need many partition to get a closer answer to the exact value of the volume. Is this okay?
Yes.
All right. So this, I think, sir did not give the name for this theorem, but he just said that if we take a function which is a continuous function over a rectangular region, then computing this, let's say, volume, I call it volume because it is nothing but the triple integration 0 to f, and then remaining is your region R. So here, what can we say, that we can always, given this rectangular region, we can compute either first with respect to y or with respect to x. So this change of order, I am changing the order of integration. This is allowed because this function is continuous and the domain is a compact set. And this, one of the famous result is which we have, is called the Fibonacci theorem. This is the result which allows you to interchange. But it, in general, for any function, any domain, this is not true. This is not true. I mean, you cannot interchange all the time. Okay, so one of the famous result we have this. Assuming this, can we quickly compute this? Given this is the region, given this is the function, we compute it.
Yes, we can.
Okay, can you quickly do it? Okay, so let's do it. Region is x from 0 to 2 and y is from 1 to 2. And function is xy minus 3xy square. And you remember what is dA? So
By dx.
yeah, so if we partition our rectangle, which is from 0 to 2 and 1 to 2, so
The final answer would be minus 11.
minus 11. Okay, let's see. Dx dy. Which did you use? You integrated it with respect to x first or y?
With x first.
Okay, let's do x square by 2y minus 3x square by 2y square 0 to 2 dy. This will be 2y minus 2 6y square dy 1 to 2. This will be y square minus 2y cubed 1 to 2. 4 minus 16 minus 1 minus 2, I think. This is minus 12 minus plus 1 minus 11. Yeah, you're right. So I think you can say that this is nothing but the volume, um, right? Volume above the rectangle R, below, above the rectangle R and below by this curve F. If I simply draw it, then this is what my, here is my, this rectangle, here is my surface. So it is bounded below by this rectangle and bounded above by the surface. So therefore it is in fact indeed nothing but the triple integration. So it is a volume. Okay. I think the significance of knowing that it is a volume, it is required, because sometimes people just write, find the volume bounded by this and that, and then that would mean that you have to write the triple integration. Okay. Here is this. One has to find the volume of the solid bounded by elliptic paraboloid. I want to spend some time in this problem because here what important is to know the graph here. So let's spend some time in drawing the graph. Can you try drawing the graph that it is being bounded above by this below by this paraboloid and by the other region, which is plane x equal to 3 and y equal to 3, is bounded by all these planes. So it's very hard to determine this, to draw this elliptic paraboloid, provided we can draw it in the other planes. Let's say if I put y0, can you tell me the graph? Hmm? Or if I put x equal to 0, can you tell me the graph?
Like it will be a downward parabola if you put x equal to 0.
It will be a downward parabola if x equal to, but okay, let me draw the graph. This is my y-axis, this is my x-axis, and this is my z-axis. And the graph is 2x square plus y. Suppose for the moment I draw x equal to 0 as you said, then the graph is y square plus z equal to 27. How do we draw it? So if we try to draw here, then this is like if I put y to be 0, z has to be 27. So it's like somewhere it is 27.
So intercept at 27.
Yeah, so it has to close at 27 and it has to open towards the negative side of the z-axis. Yeah. So the graph should be very good at drawing, but somehow should be. Yeah. Now somewhere here, let me just, so okay. Moreover, one more thing. Its base is okay. Suppose I just look at this paraboloid. If I look at into the xy plane, if I project this into xy plane, what exactly the figure will be? Since it is written it is elliptic paraboloid, it should be known that how it should be in the base. The base has to be either circular or ellipse or something has to be there, right? And it's written that it is elliptic, so that would mean that the lower base what we have is, it's not a circle, it's an ellipse. This is nothing but the ellipse. I'm not drawing in a correct way, but it has to look like an ellipse. Yeah. And the equation of ellipse is like you have to project into xy plane. That means you have to put z to be 0. So the projection will be 2x square plus y square equal to 27. And I think you must know that it is an equation of, this is the standard equation for ellipse, right?
Yeah.
Yeah, so therefore we got to know that how does it look like at the base. At the base it has an ellipse which has this equation. And the question says that you have to find the volume of the solid which is above. If I see the above part of the solid, it has to be bounded by this elliptic paraboloid. And the planes are x equal to 3, y equal to 3. Yeah, if I look at x equal to y3, so let's look at this part in the xy plane, because the lower thing is in the xy plane. So the lower part is x equal to 3, y equal to 3. And our projection of equation is nothing but 2x square plus y square equal to 27. Can we see that given these 2 points x equal to 3, y equal to 3, if I just should draw in my xy plane, this is nothing but the 3 unit square. This is my 3 3 and this is my 3 0, 0 3 0 0. This is what my projection of the planes x equal to 3, y equal to 3 in xy plane. And the projection of our surface into the xy plane would be a ellipse. Now, can you tell me how this ellipse and this square are they related? How to draw these two things? And can you tell me which one is contained in another? Is there anybody waiting in the meeting? No.
The rectangle would be inside the ellipse.
Correct. And you can also see if you put x equal to 3, y equal to 3, then clearly it will be 9 to 18 plus 9, it's 27. That means um, this point actually touches the graph. You see? So somewhere it should be like how to draw. I think it should be big enough so that it will like this, something like this. Yeah, this is your ellipse, and it should touch your whatever your uh, this figure is. All right, I think the radius of x1 is y is more. Yeah, this is how it has been correctly written. So yeah, this is okay. This is an xy plane we have. This our area. This is an xy plane. This is nothing but the ellipse. Okay, so now what I want to say here, suppose, so finding the volume is how to see the volume finally, how to see this. So suppose somebody is here, and I want to see it, the down part. So I have to, in order to find the volume, I should have certain bounded region so that I should be finding the volume. So clearly, at least this part is clear that I have to find this volume where it should start from this region. The height should be from, since your function we are always taking non-negative, so it will start from 0 to this curve. This curve is nothing but the upper bound for our height of the region. But what about the base? What about the base? Clearly your region, if I look at my ellipse region, my region of parabola, I mean elliptic paraboloid, this is quite large from the base. But what I want to look in order to say the xy, because I need to define the limits for x and y, I should be only focusing on the plane x equal to 3, y equal to 3, which is quite shorter than the region which is bounded by the ellipse. Yeah, so roughly let me just draw once again. What I want to say here is this. Mm, given this ellipse, this elliptic paraboloid, I should say, um, here is setting. Oh, wait. What was that? X equal to 3, y equal to 3. Yeah. How to draw that? X equal to 3 is this, y equal to 3. Yeah, something here. And I have to just extend this, you know. I think if I'm not drawing wrong, this is how it should be. And this is the point 2700. And this is nothing but your, what was the 3 3? It should say 330. And the remaining coordinates, I think you can say, what are those? So what I want to say here is, no matter, even if your elliptic area, the base elliptic area was quite large, you see, because that was inside your this cube kind of thing. But you have to just focus on that region which is being bounded by your cube zero, which has, I should say rectangle or square, which has units 3. Even if your base of the ellipse was quite large, but you have to bound below by that curve and bound above by this paraboloid. uh, I don't know, does it make sense?
Yeah, it does.
You mean, okay, let me just roughly, this is 0 to 3, 0 0 3 0 0 3 3 3, and I am just uplifting it. I am just, just extending the whole thing, and upper part is nothing but bounded by something like this, something like this. So we have to find the volume like this, like this. It's like a hut. Okay, you have a hut, you have something in the base, but you are making something like this, something like this. So base has to be covered by only by that cube, or your square, whatever you have, but upper part has to be bound by that surface which is given to you. Yeah. If it makes some sense to you, then you should be able to tell me the limits, because all the time we need volume, and volume means triple integration. That would mean only the limits of z, x, and y. So let's write the limits at least for the moment. So integration, so the dz, d, what do we write first? Any of them. Dx. Okay. So your height from where to where is bounded. You know our function is always non-negative. So from where to where would you take the z-axis limit? Remember z is this. This is my z-axis.
We'll take the function as the limit
Yeah.
of z.
Yeah. So can you tell me what is that? I think it's written here. So from here, can you compute what is that?
From 0 to 2x square plus y square plus z minus 27. Mm,
Well, if it is a limit
no,
of z,
we have
what
to
should be that?
compute the thing for z.
Yeah. So what is that? Z equal to 27 minus 2x square minus y square. It should be okay, right?
Yeah, yeah.
So your function is being bounded from 0 to 27 minus 2x square minus y square. Now can you tell me the limits for x and y? Remember, you have to go into x and y plane in order to see the limits of x and y. Remember?
Is 0 to 3 for both of them.
Exactly. 0 to 3, 0 to 3. Very nice. You know, if I just project my uh, paraboloid, the base is ellipse, which has more area. But I am not interested in that. I am interested in that plane in xy. I mean, xy plane, whatever the figure we have, because we are bounded below by only that much. Only that much. Although elliptic part is too much. but we don't need it. So the limits will be from 0 to 3, 0 to 3. And now can you integrate and tell me the volume? Just a moment. Let me write on the fresh page. So 27 minus 3x squared. I think it was 2x squared.
So 162 units.
162, well, yes, 162 is the answer. So I think I can just simply leave here. So uh, you did the integration in the same order, right?
Yeah.
0 to 3, 0 to 3, we will simply put 27 minus 2x square minus y square, and then this integration I'll leave it as 162 units. Yeah. Okay, so the important thing here is that all the time drawing the graph from where to where the region is being bounded, that is the only thing you have to do. Rest can be done. The integration can be done. Okay, I think it makes sense now. So let's go to question number 5. So express the region D. I think D is being visible in the figure. You have to express the region as union of type 1 and type 2 and then evaluate the integral. Hmm? If you see the graph,
Yeah.
remember what are type 1, type 2?
In case of type 1,
Mm-hmm.
if we express the limits of y as the functions of x,
Yes,
and for type 2 we express the limits of x as functions of y.
right, exactly right. Let me try to give you the essence of doing all this. So, as you said, y in terms of, let's say, function of x, if I try to write and certain x is in certain region, this is type 1, right?
Yeah.
And if I write on the other hand, if I write certain c less than y less than d, and I express x as a function of y, let's say h1y, h2y, this is type 2. Now, how to, okay, I think first you try, then I will tell how to see, how to judge. Can you partition the graph in such a way that the 2 or 3 domains in which you partition it, that will be type 1 or type 2? First of all, is the whole graph a type? Is it a type 1, type 2? Complete graph.
Just a minute. I think it can be represented as type 2.
Type 2 fully?
I think so.
Okay, if you think so that way, let's see if that is the case. Mm, just a moment. Okay. Well, I don't think so. It is completely a type because let me see how. You want to partition y, you want to write y in terms of x. That means when you try drawing um, lines parallel to y-axis, there should be exactly two curves which should bound your domain. Yeah. Let me just try to give you certain idea. Yeah. Yeah. Here, if I try to draw parallel lines to the y-axis, I start drawing from this where the region starts. Yeah. So where did it cut? The very first line cut this line, right?
Yeah.
The second line cuts which two lines? This one and that one.
Yeah.
It's okay. But if I go here, which one will you pick? This curve, this curve, this curve. We do not have two curves, right? No, I
Yeah.
think till here it's okay. I think it's okay to be here till here till here. What about this part? What about this part? So let me just give you idea. If you have certain curve, let's say bounded by, let's say these two things, these two curves, it is bounded by these two. You start drawing. If you want to write your y in terms of x, start drawing parallel to lines parallel to y-axis. Parallel to y-axis. So this region which I want to, let's say I want to count this area. I want to just, it is bounded by only two curves. You see, no matter how many lines I draw. So it will cut the very first line, cut this curve, the second line curve this. It is bounded by only these two. No matter how many lines parallel to y-axis I draw, it will only cut this curve for the first time, this cut the last time. That means it is here, it is nothing but y is nothing but a function of this curve, phi 2x. The lower bound is nothing but y equal to phi 1x. I can write integration from phi 1 to phi 2. Now reverse the way. Reverse the way for the type now. This is, for me, it is type 1. Now, why it is not type 2? When I start cutting the graph in by drawing lines parallel to x-axis, this is the first curve which cuts, and this is the final curve which it cuts. For me, this is phi 1x. For me, this is phi 2x. But till this point, I have these two curves. This is my phi 1, this is my phi 2. But as soon as I cross this part, I will get, this is my phi 1, this is my phi 2. And clearly this curve and this curve are two distinct curves. Clearly I cannot write the whole region as type 2. Do you agree?
Yes.
Because the function that should be constant throughout your x, right? Your x has to be bounded by only two functions, only two curves. But half of the domain is bounded by this curve and this curve. And half of the domain is bounded by this phi 1 prime. Of course, phi 2 is constant. So this is not type 2. Now looking at the graph now, let's look at the graph by looking whether it is type 2 or not. I'll start drawing the lines parallel to x-axis. This is my phi 1, this is my phi 2. Till this part. As soon as I cross, this becomes a different curve, phi 1 prime. These two curves in moment, they are completely different, right? So phi 1 prime and then phi 2 is same, of course, phi 2 is same. So therefore, my x limits are not constant. These two functions h1 is actually being defined only half of the domain. Half of the domain has different h1, half of the domain has different h1. Now, let's look at, this is therefore not type 2. Fully the graph is not a type 2 graph. Let's look at whether this graph is a type 1 graph.
If we
That
can
means
split the graph, then we can put it in type 2. The two
this is,
separate
yeah.
entities.
So the question is, express the region as union of type 1 and type 2. So now it is up to you how to split the graph, the region, such that that becomes type 1, type 2 or something like that. How would you split the graph?
If I split it at y equal to 0,
Y equal to 0. Okay, here. Mm-hmm.
So
How?
like from y equal to 0 to y equal to 4,
Mm-hmm.
you can say phi 1 equals to phi, phi 1x would be, yeah, we have to find it in terms of that. Just a minute.
Okay. Let's start drawing the parallel lines. Let's start drawing in the graph which you have written. So you have splitted these two parts. Is that what you want to say? Or this whole graph is one graph and this is a one graph? What do you want to say here? I'm not getting.
No, initially I said we should partition from y equal to 0.
Yeah. This is my y equal to 0.
That's
Or
x equal to 0.
sorry, this is both x and y both 0. Sorry. This is my y equal to 0. Okay. Now,
Just a minute.
yeah, you think for a minute it will come.
Like, how do we express y equal to x plus 2 whole square in terms of x? That's where I'm getting stuck.
Okay. Sorry. Can you repeat?
Like, we have one curve as y equal to x plus 2 whole square.
Yeah.
Like, if we split it from y equal, if we take a partition from y equal to 0 to y equal to 4,
Mm-hmm.
and we consider both of these curves, then one
Mm-hmm.
curve is x equal to y minus 1 by 16 y cube. That's okay. But then we
Mm-hmm.
also have to express the other curve in terms of x.
Yeah.
And that's where I'm getting stuck.
Mm-hmm. So basically, it looks to you that one graph writing in terms of x is easy, but another graph writing in terms of x is difficult. I mean, x as a function of y is difficult. So why don't you partition then? Who is saying the keep the both the graphs together?
Okay.
Mm-hmm. Now, can you think of? Does it simplify?
It does.
Now, can you tell me which one is type 1, which one is type 2?
Like for D2, it would be easier if we do it in terms of type 2.
Type 2, yes. Oh, type 1, I think, right?
No, type 2 for D2.
D2, yeah. Type 1, I think. I want to say. D2 is
No,
this.
for D2, it's easier to express in terms of a function of y, the graphs.
No. Hmm. Well, if I ask, yeah, I think for D2, y itself is a function of x, right?
Yeah. So
Okay.
so the curves would be y equal to 0 and y equal to x plus 2 whole square for D2.
Exactly right. Exactly. So, okay, let me just write what you want to say. So, domain D1. Oh, this is not visible. Let me take another color. D1. D1 is all those x and y such that where is your x lies? Can you tell me that?
X lies from x equal to 0 to x equal to y minus 1 by 16 y cube.
No. I'm asking. Sorry, D2. Sorry. D2.
In D2, I was saying we can do it from y equal to 0 to y equals to x plus 2
Yeah.
whole square.
Y lies between 0 to x plus 2 whole square. Very nice. What about x?
X is from 0 to minus 2 or minus
Minus
2 to 0.
Yeah, minus 2 to 0. Now let's write D1. Let's write D1. Okay, let me just shift these here. D1. How, what is it? What type? First of all, we have not discussed type. This is type. D2 is type.
Type 2.
Type 2. Very nice. No. It is type 1, right?
Mm,
Remember,
okay.
type 1 is this. Y is
Okay.
function of
Okay.
x.
Okay.
Yeah, so this is type 1. This is type 1. What is type for D1?
Type 2.
Type 2, right? Why? Because we are somehow writing x in terms of y. So we are writing, remember you draw the parallel lines to the x-axis. There is unique curve. You start from this, which is nothing but your x equal to 0. And you end up by writing x equal to y minus 1 by 16 y cube. Is that okay?
Yeah.
And here you draw the other lines in this D2. You draw these lines parallel to y because in this you are writing y in terms of x. And clearly the base starts from y equal to 0 and goes till x plus 2 whole square. That's all. One curve. Two curves are determining the whole graph. Right? So this is type 2. D1 is type 2. Can you tell me the final D3? What type is it?
D3 will be type 2.
Yes, D3 is indeed type 2. So if we draw, type 2 means you have to write x in terms of y. So whatever you have to write in terms, you draw the line that. So you have to draw the line parallel to x-axis and there are only two curves determine the whole graph. This is your phi 1x. This graph is your phi 2x. Is that okay?
Well, I can recall one thing,
Mm-hmm.
that like in we had something called the technique of strips. So if we start cutting strips, we had to
Mm-hmm.
make sure that the strip we should have one strip for every iteration. Like for
Yeah.
example, in domain 3, if we draw vertical strips, then after a
Mm-hmm.
particular point, for one strip we
Mm-hmm.
would have two portions,
Yeah.
and that's why that makes things more difficult.
Right. Exactly right. Yeah. This is how we have to see it. And now I think you can write the D1. It is all those x and y such that, yeah, so such that where does your y lies? Y is from
0 to
0
4.
to, and x lies between 0 to the curve y minus 1 by 16 y cube. This is okay, right?
Yeah.
And now similar thing you can do for the domain 3. Domain 3 has all those x and y such that where does x lies? Sorry, y lies?
Y lies from 0 minus 4 to 0.
Yeah, minus 4 to 0. And x has the same curve, right? This is the same continuation of the curve.
Yeah.
So x is exactly the same. 0, comma y minus 1 by 16 y cube. I think this is all one has to see. Once you
X would
understand this
begin from
part,
minus 2 in this one.
just a moment, what did you say?
X will be from minus 2 to y minus 1 by 16 y cube.
Ah, right. This starts from minus 2. Yeah, you are right. Very good. Okay, so I think we have defined the domains very correctly, I think now. And you can integrate it now, right? How would you do that? So since you have to integrate over the domain D, and we also know that D is nothing but D1 union D2 union D3. Therefore, our
We would
integration
integrate them
towards,
individually and add them up.
sorry.
We can integrate them individually and add them up.
Yeah, so just to do it, and I think I'll just leave it. D3. And this will come out, I'll just simply tell the answer, you can verify later. This is, yeah. Yeah, I think with this you should be able to understand now type 1, type 2. Okay. And sometimes this is how we do not know how to integrate the function fully, but we can partition so that we can do it in partition and sum up all, we get the complete answer. Okay. Yeah, this one.
But
We
okay, I
have to.
had this question
Mhm.
that, like for the previous one, for the human, it is difficult to do it all together. That's why we partition it in different
Yeah.
parts.
Yeah.
If I give it to the computer, will it
Mhm.
partition it or will it do it all together?
I certainly have no idea because there may be codes where mm, you can do it directly. I am not sure. I have no experience with the computer. I have never tried, in fact.
Okay.
Maybe somebody can try doing it. I don't have any idea. But it's a good thing you can do it and check whether what to write as a code so that you can do it fully in one go. I, but I don't know. Okay. So next question is about again by finding the volume of certain solid and which we are bounding by certain planes. Hmm. X equal to 0, y equal to 0. X equal to 0 gives you which plane? Can you tell me which is the plane when I put x equal to 0?
It is the YZ axis plane.
Yeah, it's a yz plane. Y0 gives me xz plane. Z equal to 0 gives me xy plane. All together, they should be giving me a figure where I can find the volume bounded by certain planes. Yeah, can you simplify this whatever this is given to you in order to compute where it is exactly being bounded by?
But like the three of them would converge or intersect at the origin.
Three of them with, yeah. So does it say anything?
Okay, so we have to make the graph by that function.
Yeah, you have to somehow see what they are trying to say you. They are saying that you have to be bounded by certain planes. Yeah, if this is z equal to 0, that would mean that it has to bounded by this in the xy plane, right? This is the curve in the xy plane where you project it and see it where how it is being bounded by. Do you see this?
Yeah.
So now can you try just like we did it in the previous case? We projected to the xy plane, we saw what is in the xy plane, we defined the limits for xy plane, and remaining is given by the surface and then triple integration that should give the volume.
I would need some help for this one.
You need help?
Yeah.
Okay. This is my x plane. This is my sorry. This is my x plane. This is my y plane. This is my z plane. Okay. So first of all, we are given by certain surface, which I don't know how to draw, but there is certain surface.
Like in a
Let me.
2D plane, we can draw a line, but how to draw the plane?
Yeah, of course, we are not drawing the plane. You just have to imagine what is exactly being happening. You don't have to draw what exactly does it, how does it look like. If you can draw, it will be good to see. But if you cannot, you don't have to actually. This is what I want to say. Hmm. So I just say that suppose you take x equal to 0. Suppose you take, then it is nothing but 3y plus z equal to 6. You somehow can draw this, right? It's a line in YZ plane, right? If
Yeah.
you take y to be 0, you can somehow draw 2x plus z equal to 6. And from there, you can combine to give a graph inside xyz plane. This is the roughly idea. Yeah. So
Yeah.
let me just try to. I think it should be a tetrahedron because there are three lines. It should be a tetrahedron. Mm, let's draw in YZ plane. X equal to 0. This line. Can you tell me where are the coordinates from where it will pass? Some information you have to give.
Okay,
So
like when z equal to 0, y equal to 2,
y equal to 2, and when
and when
y is 0,
y equal to 0, z equal to 6.
uh, something like here, right? 6. Okay, so it should pass. It should pass. What about x and z plane?
Yes, and also since the degree is 1, we can confer that it's a straight line only.
Yeah, yeah, this is a straight line. Of course, it's a straight line passing through these 2 points. Same thing for
For y equal to 0, we will have z equal to 6 and x equal to 3.
x equal to 3. Yeah, so something like this. And if I look it into xy plane, it should be combining these 2 points. This is what my feeling is. If I look in the xy plane, can you see is that line what we want? So it's a 3D tetrahedron. Yeah, it's not just what you see. There is a something inside and there is a behind. There is something. You see, it's a 3D figure. I somehow don't know how to draw it, but
And
it's a
it has
3D.
4 faces.
Yeah, it has more faces. It looks like it has only three, but it has more. So it's a tetrahedron. Yeah, this is what roughly our figure is. What do we have to do is that you have to find the volume of this. It's simply easy, right? Your height is being bounded by that curve which you are writing. I think I'm not writing the plane, but the plane is this. So the z has to be determined by 6 minus 2x minus 3y. This is your surface. This is your xyz uh, surface. I don't know how to because I have just drawn the lines. Okay, I mean these are just the walls. I should say these are just the walls of that. The graph looks different. Um, so now height I know it has been determined from 6 minus 2x minus 3. It has to be bounded below by that and above by z equal to 0. It's written. So height I know. How to determine the xy coordinates, right? The limits for the x and y axis. So you have to
Simply, we can put the limits for this
simply
function.
put, yeah. So can you help in writing the volume? So volume equal to, as we know, volume is triple integration. I will just simply write dz, dy, dx. Z is being bounded by certain surface that you know. Hmm? What is that?
Yeah. 6 minus 2x minus 3y.
Yeah. Now, in order to determine the limits, because it is bounded below by, it is bounded below by this plane, I should say, something like this. So, can you tell me the limits for x and y from that?
Y will go from 2 to 0.
Y will go from, and where does x goes?
X will go from 3 to 0.
There is one, just want to say one thing.
It,
When you
uh,
project, okay, when you project your graph to the zx, to the xy plane, okay, then what do we get? We get 6 minus 2x minus 3y equal to 0. So it is
yeah.
being bounded by this thing and the limits whatever you are given to you. So you either write y in terms of x or x in terms of y. I don't mind it, but it has to be bounded below by this, right? This curve. So you have to write this. So let me just write y equal to 6 minus 2x by 3. This has to be your y. Hmm? But from 0 to this. But given this part, now you can tell the limits from x where to where. Yeah, because y equal to 0 would give me that 6 minus 2x by 3 equal to 0. This would give that x equal to 3. So when your y is highest with 6 minus 2x by 3, then x has to be 3 there, starting from 0. So it has to start from, of course, the limits are starting from the y and z, y equal to 0, x equal to 0, that is given to you. That is given to you. But it has to below by a certain thing, right? There is a line which you have to see. So if I try to draw this line in the xy plane, it is something like this. This is like 2x minus plus 3y equal to 6, I think. This is nothing but 3, 0. This is nothing but 0, 2. So you have that you are in this graph now. In xy plane, you are like in this plane. You have to start from x equal to 0. That means it has to be bounded by this part. It has to be bounded by this part and the line. Yeah, so there is a region in xy plane. You cannot ignore that region. Now within that region, you can either partition it graph 1, type 1, or you can partition in type 2. Yeah, it depends on you. I will write y in terms of x. With the type 1 only. So y will be 6 minus 2x by 3. So my limit is 6 minus 2x by 3. And x now. X you can see either you go from 0 to 3 here, or you can change the type and then go from y from 0 to 2. So then you will go, x is go from 0 to 3. Is this okay?
Yeah, yeah.
So this is how you have to determine this region. Of course, you have to make sure that the region is being bounded by the line.
Okay, like could we just repeat one thing? How did we get the limits for y? Hello.
Hello?
Now you're audible.
Yeah, sorry, the network was very poor. Let's go back. So one has to just take care that there is a triangular region in the xy plane, because you know what you have to see. You have to project your surface on the xy plane and look at in the xy plane itself how many things which are there. It's like it is being bounded by line x equal to 0, line y equal to 0, and line 2x plus y equal to 6. So there is a region where you have to take care of that, because you know this part has been taken care. The remaining part is nothing but the area. But area has to be bounded by certain things, right? But those things are nothing but the lines 0, x equal to 0, y equal to 0, and the line 2x plus 3y equal to 6. And that is nothing but a region where you have to determine type 1 or type 2 and do the volume, do the things. So this is okay, right?
Just a minute. Okay, like we are taking the limit of y from 0 to, just a minute.
0 to 6 minus 2x by 3. I am taking it into the type 1. It's like starting from uh, 0 to this, 0 to this, 0 to this. And this equation is nothing but 2x plus 3y equal to 6. So starting from 0, I'll just go to this part, and x is varying from 0 to 3.
Okay, like we are taking y equal to y from 0 to 6 minus 2x by 3.
Yeah.
And while determining the limit for x, we just put in the value and check what x would be at that point.
Well, you can either do that or you can simply look at the graph. Yeah. This is this graph. If I just show you here in this part, it is this graph. But this would look like this if I just draw into the xy plane. Like if I put x here, y here, this is how it will see here.
Like also from the graph, like we would interpret that as y moves from 0 to this line, x moves from 0 to 3, and that's how we put the limits.
Yeah, yeah, yeah. Either of the way you can see. Yeah, correct. If you, of course, if you go to y equal to 2, then x will be 0. If you go to y equal to 0, you will get x equal to 3. Yeah, so okay, so I think it should be okay that you just cannot ignore the limits directly. You cannot write 0 to 2, 0 to 3. Otherwise, there is no region actually. If you go 0 to 2, 0 to 3, it's not the region because you will go more. You will go here. Yeah, you'll add up this more. If you add up 0 to 2, 0 to 3, it would mean that you are writing the rectangular region 0 to 2, 0 to 3, which is the complete rectangle. But we are not dealing that. We are just bounded by a line which has to be taken care. And this line came because we want to project a certain thing in the xyz plane. You have to look into the xy plane. How does it look like in the base? The base, it looks like a triangle. The triangle has to be pulled above to draw the graph, to draw the tetrahedron, and the height has been maintained by that z. So you just have to take care of all those things. This is this okay?
Yeah, it's okay.
I think you spend some more time or some exercises. You'll realize that what exactly you have to do. You have to take care all the planes which they have written x equal to 0, y equal to 0, and then z equal to 0 will give you another line which you have to take care in the xy plane, and then how the region in the xy plane, that is very crucial. And because the limits of x and y, they have to be determined by how the region look like into xy plane. Yeah, so this is how. Okay. Hmm. Yeah, another question. Find the area of the region bounded below by y equal to x square. I think you should be able to do this because this is in 2D. I'm finding area only.
Yeah.
And the graphs are also simple enough. Yeah, are you able to see the region at least?
Yeah, I can see the region.
Oh, okay, let me, you just help me in drawing the graph. Okay, it's a 2D graph, so let's draw x-axis, y-axis. How does this graph y equal to x square? What is this?
It's upward parabola touching at x equal at the origin.
Okay, it cuts the origin, very good. Yeah, this is how it should look like. But since it is written that we are only worried about where?
The first quadrant.
First quadrant. This is important. We are only worried about first quadrant, so I'll just, although I can keep, but let's just focus on the first quadrant. And the other graph, y equal to 2x.
It would be a straight line
Yeah, straight
that
line.
would pass through origin and cut the curve at 2, 4.
2, 4. Yeah, so if I have y equal to x square, y is also equal to 2x. That would mean that x has equal to 0. At x equal to 0, it will cut x equal to
Your audio is gone again.
hello.
Now you're audible.
I'm really sorry that this network is quite poor here. Okay, let's come back here. So, okay, x equal to 0, then y equal to 0. When x equal to 2, then y equal to 4. So, this is nothing but 2 comma 4. This is 2 comma 0. So, what is the region? In the first quadrant, it's written below by y equal to x square and above by the line. So, the region is
Like if we take it in terms of x, for example,
mm-hmm.
then
So,
will
do you
then
agree that this is the region?
yeah.
Okay, let me write this first. This is the region. Oh, I don't. Sorry, I don't want to draw the how I partition it. Okay, I sorry this. Okay, so this is the graph. Let me just say this is the region. How to integrate? Now, finding the area is what you have to find. You have to take the double integration. You have to find the limit for y. You have to find the limit for x. And it's up to you how to find. Which one do you find more easier? Which type?
Okay, like if we take it in terms of x, then it
Mm-hmm.
the lower limit is the curve y equal to x square,
Yeah,
and the upper limit is y equal to 2x.
yeah.
And
So how would you take
and
it as
x
a
would
type?
vary from 0 to 2.
Mm-hmm. This is 0 to 2, yeah.
So it would be the double integral of
Mm-hmm.
like dy dx. The inner limit would be x squared to 2x. The outer limit would be 0 to 2.
We are writing dy dx, right?
Yeah.
0 to 2. Where y is from?
Inner is from x squared to 2x.
Exactly right. If you change, okay, this is what type? Can you tell me the type, the way you are writing the area?
This is type 1.
Yes. Y in terms of x means type 1. That means if I draw the parallel lines to the y axis, there should be only two curves, which we can see only two, right? This one and this one. So it's pretty simple. And if of course I can visualize the same graph into type, let's say this is how the graph look like. I can also see the same as type 2 because only there are two curves which are being bounded the region. One is this one is this one. But writing, of course, them in terms of y will not be very simple, but of course one can write this is y by 2, and since y is equal to x square, you have two choices, x equal to plus minus root y. Which one will you choose?
Yeah, the previous one.
Yeah, you will choose root y because the graph is nothing but at the positive side of y axis. So you have only positive values, so root y. So you can either integrate this way, you can write it dx dy, and your x starts from y by 2. Yeah, it starts from y by 2. Y by 2, it will go till you have to just define how where you are pointing first and where you are ending first. You starts with y by 2, you end with root y. And of course, if you see, then your limits of y will be 0 to 4. So here 0 to 4. And if you see, they will give you the same answer. Can you quickly tell the answer?
4 by 3.
Yeah, exactly. 4 by 3. So answer is 4 by 3. Yeah, very good. Okay, so we know how to find this. Now there is one more thing which we want to define by changing into polar coordinates. Hmm? What are the polar coordinates?
Like for a circle, the polar coordinates are r cos theta and r sin theta.
For circle, is it just for circle?
No, not just for circle.
I mean, if I have any point in Cartesian plane meaning xy plane, I have one point xy. And I think you know it how to write it in terms of another way where there are two parameters just like
We
x and y.
consider the angle which it makes with the x-axis.
Exactly. So this is your r, this is your theta, and this will completely determine your point, right? If your
Yeah.
this norm is fixed, if your theta is fixed, isn't it? It will tell you the xy,
Yeah.
and it will fully determine your point. So the two parameters r and theta will actually tell you everything. And by trigonometric ratios, we all know that if this is my x, this is also same as r cos theta. If r is nothing but the norm of vector r. Hmm. And this y is nothing but r sin theta. Yeah, this we already know. So any point in the Cartesian plane, you can always write into polar coordinates by writing x equal to r cos theta, y equal to r sin theta. Where? Where what is r? Where what is theta? That one has to say. Yeah, so how? X equal to r cos theta, y equal to r sin theta by, sorry, I just simply say x square plus y square, it will give me r.
Yeah.
Where r is nothing but root of x square plus y square. Why? Because modulus is always positive. I cannot take negative. And theta is simply what? Tan inverse y by x. So given x and y, I can tell you r and theta. Given r and theta, I can tell you what is x and y. Yeah, so they are completely determining each other. All right, knowing all this fact, can we change the polar coordinates to find the integration? Since we have change everything, all the coordinates. Now, what is the meaning of this integration? Let's see that. So we have to integrate x plus y dx dy over the domain D. What is, sorry, over the domain R, let's say. R is nothing but, it is all those x and y such that 1 less than equal to x square plus y square less than equal to 4, and moreover x is less than equal to 0. This is important. Hmm?
Yeah.
In order to change everything, I have changed x and y. I can now simply write them by r common cos theta plus sin theta. Yeah, this change is visible.
Yeah.
I have to change my domain. I have written what is x square plus y square. Now I can tell what is my r square, right? So r square lies between 1 and 4. Does it say what is r? Can I tell the domain for r?
Between 1 and plus minus 2.
Plus minus
But
2. But
but we are considering the negative side.
negative or positive? It should say this, right?
Yeah.
Yeah,
Yeah.
so
Okay.
so your r has to be in this. So you have determined your limits of r. 1 to 2, d. Okay. One thing. How to change dx dy into dr d theta? That is another challenge. Hmm? Simply
Hmm.
writing x to be r cos theta, y to be r sin theta. I don't know how to write dx, how to write dy.
Okay, just a minute.
Hmm? Take time. Think about it. Okay, here is the thing.
I got a relation here. I don't know whether it's correct or not.
Say it.
Like dx plus dy equals to r into cos theta d theta plus minus sin theta d theta.
Oh my god, oh my god. This is too much complicated. Does it say anything? Does it give you anything?
I was thinking if you had to compare on both sides, but like I get cos theta minus sin theta, so we can't compare.
Mm-hmm. Okay, here is the thing. Maybe you keep doing. If you get something, tell me. Otherwise, here is the hint. If you change certain function, let's say if I write my x as a function of uv, if I'm changing the parameters, just like I'm writing x as a function of r and theta here, it's a function of r and theta. You agree, right?
Yeah.
Suppose I change a certain variable in terms of another function, let's say f and guv. Then remember writing dx dy is nothing but
Okay, got
the
it. I think.
Jacobian. You remember
No, not
del
this.
x by del
Okay,
u,
yeah, you go on.
del x by del v, del y by del u, del y by del v. Take the determinant, take the modulus.
Yeah.
Yeah, so this is nothing but the change of variable tells you that if you have change of variables one function to other, then the small change in this dx and dy, the length of x and y, it is nothing but the determinant of the Jacobian matrix, its modulus. It's modulus. Okay, knowing this, since
Okay, we can do it like this as well. Like
yeah,
we have taken. Okay, we have taken x equal to r cos theta, for example.
mm-hmm.
If we do dx by d theta, we get the value
Mm-hmm.
for dx in terms of a function of r and theta and d theta.
Yeah, okay, suppose I know this. Now,
Can we substitute this somehow?
mm,
It
well,
seems
I
problematic.
think, well, I think you can do dx by d theta. No, I don't think so. Let me just write this way. Dx by d theta into d theta one can write. Dy can be written as dy by d theta into d theta. Does it say anything? Or equally, I can say dx. Sorry, dx by dr to dr, dy by dr into dr. I don't know directly how to say it. If it is, it's a single thing, then I could have said, right? If x is just nothing but t, it is just simply dx equal to dt or x
Yeah.
equal to t square. Then I could have said like dx by dt is 2t, and then dx is nothing but 2t dt. It's a simple thing, simple fact. But if you have a function of two variables, I don't know how to say. Okay, so let's follow the same convention. You have to write del x by del r or whatever the convention is, cos theta, then minus r sine theta, and then sine theta, and then r cos theta. Take the modulus, take the determinant. What is that?
R cos squared theta
Mm-hmm.
plus r sine squared theta
And then,
equal to r.
yeah, so dx dy is nothing but dx dy is nothing but r dr d. This factor will tell you that along with dr d theta, something else would come. Okay, so this would be r dr d theta. Okay, we had limit for r from 1 to 2, but theta limit, how to determine the theta? Yeah, something is given to you. If we carefully see the graph, this lies between 1 to 4. What is this? This is a circle. Two circles we have. One circle is radius 1, one other circle is radius 2. You agree?
Yeah.
And the region is between those two circles. Yeah, this is
Hmm.
the region. And x is negative. This is crucial here. Can you tell me which is the quadrant where x is negative?
Second and third quadrant.
Second and third quadrant. And can you tell me the angle for the second and third quadrant? This is what we were looking for. So the
It's
graph
pi
is
by 2 to 3 pi by 2.
exactly right. So the theta angle is pi by 2 to 3 pi by 2, and this is how you will write your limits for this. Does it make sense?
Yeah.
Right. So this is what you have to integrate. I will leave to you to integrate. It is not that difficult. Okay, so with this, I think we know now how to change into polar and then how to simplify questions. There's one more question. And if we get time, we will discuss more. Otherwise, at least one more. Okay, here one has to again evaluate the integral, where d is the region bounded by the polar axis. Polar axis means we are in the r and theta. Where and it has to be also bounded by upper half of the cardioid, which is r equal to 1 plus cos theta. So before that, you have to see the graph. Unless you see the graph, there is no possibility how to draw, how to see the integral. Okay, let me quickly tell such kind of questions are sometimes important. You have to draw 1 plus cos theta in the upper half. Upper half meaning suppose this is my r, this is my theta, polar axis. What is the upper half?
The first and second quadrants.
Yeah, first and the second coordinate. So this is my upper half. Okay. So now, if I just try to draw this graph, I will just help you how to draw certain kind of graphs. You start writing by theta equal to 0. R equal to 1 plus cos theta. For theta equal to 0, what is its value?
1.
Is it 1 or 2?
Yeah, 2.
Cos 0 is 1. So the value is 2 at, so this is my value. The graph starts from here, here. At theta equal to pi by 4, can you tell me the value?
1 plus 1 by root 2.
Yeah, 1 plus 1 by root 2. Is it more or is it less than root 2?
It's less than root 2.
It's less than 2 clearly. So somewhere, since angle is pi by 4 is exactly in the half of this is my pi by 4. The value is less than that. So it looks like um, the graph should be like this. Eh, Are you following? Something like this. Something like this.
Yeah.
Okay. If I go to pi by 2, what is the
Then
value?
it's 1.
And it's 1. That means it has to come down. So roughly it should come here. Is it okay?
Yeah.
I mean, I should draw one bit above because the way I have written here, it should be here. Let's draw here. Yeah. Now, let's draw bit negative side because we need upper half. If I draw, what is the next angle? Pi by 2 and plus pi by 4. Can you tell me what is that? Cos pi by 2 plus pi by 4.
At pi, it would be uh,
Cos pi.
just a minute. Yeah, at pi, it would r would be 1.
Is it 1 or 0? What is cos pi?
Okay, cos pi is minus 1. Yeah, r would be 0.
Yeah. So somehow I just try it will come like this. Okay, I'm telling you this. It will come like this. The graph is, of course, it doesn't look like this. It looks better. I am drawing very bad, but Okay, just a moment, my pencil battery is gone. Okay, so here I'm just drawing it roughly. It will come like this. It somehow it will come like this, and this is just upper half. If somebody wants to draw in the lower half, it will come like this. This is how the graph will actually become, but we don't need it. We just need the upper half. Okay, all right. So roughly this is the graph. If you want to integrate, now it's all about integration and finding the limits. Just tell me the limits and then we will be over. You will solve the integration. I will leave it to you.
The
What
limits
is
for
r? What is
theta would be from 0 to pi.
okay? How are you drawing the graph? I mean, are you writing type 1, type 2? It depends. Tell me. Are you writing r in terms of theta?
Yeah, that's
Yeah, you are
easier.
writing. That's easier. So that means your graph is from. Am I confusing?
It would be type 1 if
Okay,
we
no.
consider.
However, the
Oh,
type
no, no,
is,
no.
I think
R
it
is
should be type.
equivalent of the x-axis, so it will be type 2.
Okay, oh whatever the type, I don't care about the but the limits are. My pencil is not working. Okay, so finally the integration. Let's draw. Let's write the limits. The function is r square sine theta times r dr d theta. From where to where r is lying?
R would lie from 0 to 1 plus cos theta,
Exactly, and theta.
from 0 to pi.
Yes, that's all. So this whole angle is from. Sorry, this angle is from 0 to pi, and the r is of course from 0 to, sorry, 0 to this graph, and therefore the limit is 0 to 1 plus cos theta. Theta is from 0 to pi, and whatever the function you have, dr d theta. I am just leaving this computation. The answer will come out to be 8 by 5. You can later check. This is okay, right? How to draw the graph and how to see it.
Yeah.
Okay, all right, so far so good. Volume of the solid. How many questions are remaining? Let me just see. I think two more. Let's just find the limits and then we will simply leave it. Okay, so we have a solid which is lying under the paraboloid. It is the similar figure almost, and above the unit circle on xy plane. I think this should be simple enough.
Like the level surface of a paraboloid is a circle itself.
Yes, it is the same circle. In fact, if you see, remember this graph. Let me show you once again. This graph. Its base was ellipse, which was bit more than what we had in the base. Base was just a square, 3-unit square. However, the base of paraboloid was big enough. Here, let's come back. If I project my paraboloid to the xy plane, what is the equation in the xy plane?
It
Huh?
would be x square plus y square equal to 1.
Yeah, so this is nothing but this is the projection of paraboloid to the xy plane. My spelling is wrong. XY plane, and the region bounded above, already they are saying it is the unit circle. Unit circle has equation.
X square plus y square equal to plus minus 1.
Plus
No, no, no,
minus 1.
1. 1,
1
1.
only. Yeah. So whatever graph your it has been covered by above part, it is the same when you project to the xy plane, it is bounded by that part only. So if you see carefully the graph, so paraboloid I have to look by taking x and y both 0, the starting point is z equal to 1. So I will just simply write this is my z, this is my x, this is my y. uh, so z equal to 1 is the part where it just touches the z axis and it opens toward the negative side of the z axis, this side. but it is bounded above by unit circle. Unit circle lies somewhere here, right? If I draw the unit circle here, it is like,
On the
it's
plane
like,
itself.
yeah. So I have to somehow, you know, the graph is nothing but this part. This is my circle and this is my parabola. So roughly this is my graph. If I just enlarge it, if I zoom it somehow, it should be like this. I mean, roughly. I am not saying it nicely, but this is what it has to be. The upper curve is nothing but z equal to 1 minus x square minus y square. The lower curve is nothing but square plus y square equal to 1. Yeah, can you tell me just the limits and then we will just talk. Okay, one has to find the volume, remember? So one has to find the triple integration dz, dy, dx. What is the limit for z?
0 to 1 minus x square minus y square.
1 minus x square minus y square. Very good. What about y?
Mm, oh,
It's a complete circle, remember?
yeah.
So in the xy plane, we have this. And you are just like bound, you are just uplifting this to get a parabola kind of thing, like that, somehow. Yeah. So the limits are, it depends. Like your half of the, if you see the circle, your upper hemisphere has an equation which is y equal to root 1 minus x square. Hmm? The lower
Yeah.
part has an equation y equal to minus 1 minus x square. Right? So you have to just find the region and then it is type, either of the type you want to see. It is, okay. So let me just draw from here to here. You have to go. It is this equation to this equation. The lower part to the upper part. So the equation will be minus root 1 minus x square, 1 minus x square, and x is from
Minus 1 to 1.
minus 1 to 1. Yeah, very good. So I think what I want to say here is this part, that you can change the axis and it will be simple. It will be simple. Why? Because unit circle, it's a x square plus y square equal to 1. So you have region between this, right? So
Yeah.
r lies between 0 to 1. This is the region. If I take x is r cos theta, y is r sin theta, I'm not writing. And therefore this part will become, so it will become 0 to 1 minus r square because you have x square plus y square. Then certain limits for r, certain limits for theta. And there it is r d theta, as you remember. Am I missing something? Okay, for the moment you write only the same thing, x square plus y square dz, and from dx dy you start writing r dr d theta. Now there is no issue. Now if you have a circle, what is the angle between that is being, it is being taken by completing the complete circle, and what is the r? R is just 0 to 1. Theta is complete 2 pi.
Yeah.
It's not half circle, it's a complete circle. Okay, so I can simply integrate now by again writing this fact as 1 minus r square. If I take the z-axis, it has no function with this, it is just constant. So the same limit will come as a function, 1 minus r square. I'm writing r dr d theta. R is from 0 to 1, theta is from 0 to 2 pi. So this is what your volume is. Anyway, I think it should be okay. And same thing for this. Yeah, use polar coordinates to find the volume inside the cone. If you try to see this cone, let me just draw the cone for a moment. Let me just draw the graph, light the limit, and then you will solve it. above the xy plane, above the xy plane that you have to see. So you have to see that how you project, when you project to xy plane, how does it look like. Hmm? So first of all, the projection of surface to the xy plane is nothing but 2 minus x square plus y square equal to 0, or simply this. That means x square plus y square equal to root 2 whole square. So the base is nothing but, if you see the base of your cone, that is a circle. Yeah, anyway you draw, when you draw a cone, it is always a circle, right? This is big circle, smaller, smaller, and then this is how it becomes a cone. Cone has been obtained by drawing, uh, by keeping the circle one above the other, by reducing the radius of the circle. Yeah, this is how we draw the cone. Okay, so we know the surface. Now we have to find the volume of this cone. But is it this cone, or is this cone? Which side is the cone? I don't know uh, the figure. It has to be told by, you can see the figure by looking at the surface again. Z equal to 2 minus x square plus y square. Can you tell me where is the cone? Is it opening towards Z, or it is closing towards Z? Yeah, can you tell me something?
Okay. Like if you take any arbitrary value for x and y,
Why don't we take it 0? X and y both 0. That will tell you something, isn't it?
yeah,
So if you take x and y 0, what is the Z?
that is root 2.
I think I have missed the graph. Sorry, the graph is, the curve is not this, but the curve is this. 2 minus under root x square plus y square. Sorry, my bad. It should be 2 square and then 2 minus. Yeah. Yeah. Now can you tell me what is the z value? Sorry, 2 minus.
That is 2.
Yeah, z is 2. So if I look here, z is 2. Therefore, uh, cone starts or cone end at. The point is towards this, right? And base is nothing but a circle of radius 2. System. Does it help you like to
And
see
yes,
this?
suppose this was an inverted cone and
Mm-hmm.
it points at z equal to 2. That means if we tried to find the base, then we would find something undefined completely.
Sorry. Can you repeat?
Suppose we had the equation of a cone which opens
Mm-hmm.
upwards
Okay.
and it points at z equals to 2 itself. That means if we try to find its projection on the plane, we
Is
will
this what
find
you want
something
to say?
undefined. We won't get exact value.
Is this what you want to say?
Yeah.
Okay. Then.
Then if we try to substitute x and y equal
Mm-hmm.
to 0, then we won't. No, not that. If we try to
You know,
substitute z equal to 0, then we would find something undefined.
it has been already written that it's a volume which is nothing but the cone and above the x-axis, right? So if you keep your axis above, does it have any bound? No, right? If it opens towards this and you are keeping all the y-axis, x-axis above that, you are writing above xy plane, do you get any bound? No. But
No.
if you invert it, of course, then you above the xy plane you have certain volume you can find. It makes sense, right? I mean, the
Yeah.
question will tell you, even if you don't know. I may not be able to give you more precise answer, maybe, but I think the question itself will tell you how to invert the cone, how to keep the cone. Does this somehow answer your question?
Well, I
Or
was just
maybe
telling about the possibility. Like,
no, I
if we
understand.
get such a
Maybe.
weird case, then it would go till
Mhm.
infinity upwards.
Uh-huh. Okay, I will see maybe how to draw the one of the graph, and then maybe I will tell you next time. I am not sure how to say now. Okay. All right, so looking this graph now, it is pretty simple how to write the limits, because your z is from 0 to 2 minus under root x square plus y square. And when you project it to xy plane, you have a circle x square plus y square 4. Now you can pretty well write the same thing which we had written earlier, r dr d theta. You have a complete circle, radius 2, theta 0 to 2 pi. You'll do that, right? The remaining part you can do. Okay, let me just write quickly. 0 to 2 pi r dr d theta, and finally you can write it as 2 minus r dr d theta, and 0 to r is 2, 0 to 2 pi. Does it make sense?
Yeah.
All right, so I think it's good to stop here. We already had so many discussions, so much we had discussed. Okay, was that everything okay? I mean, are you were able to follow?
Yeah, I was able to follow.
Okay, all right then. See you next time. Bye.
Bye.